In this problem, we are going to calculate the reaction forces of a beam with a point load. This is a point load because it's acting at a single point on this beam. When we solve this type of problems, we are going to consider a simply supported beam, which means that we will only consider vertical reaction forces but not horizontal ones. R1 is the reaction force at the left support, and R2 is the reaction force at the right support. The day of the exam, you will have a booklet with the formulas that you may need. The ones that we are going to use in this problem are the equations of equilibrium and the formula of a moment of a force. These are the equations of equilibrium. The first one says that the sum of forces in the horizontal direction is 0. As I said before, we will consider a simply supported beam. This type of beam doesn't have any horizontal reaction forces, only vertical ones. So this means that we won't be using this equation of equilibrium. We are going to use these two. This one means that the sum of the forces in the vertical direction is 0. Here we have the vertical forces. We need to add them together and equal 0. This equation of equilibrium means that the sum of the moments around the point is 0. We need to select the point, calculate the moments caused by these forces, add them together and equal 0. We will also be using the formula of a moment of a force, which is force times distance. To solve this type of problems, we are going to follow these steps. First one, the sum of the forces in the vertical direction is 0. Second one, the sum of the moments around the point is 0. We will have to select the pivot to calculate the moments, and we need to know if the moments that we are calculating are clockwise or anti-clockwise. And in the third step, we need to solve the two simultaneous equations that we are getting from steps 1 and 2. Step 1. The sum of the forces in the vertical direction is 0. We need to find out which forces are positive and which forces are negative. This one goes down, so it's negative, and the reaction forces go up, so they are positive. The sum of the vertical forces equals 0. The positive forces are the reaction forces, which are R1 and R2, and this force is negative, so minus 20 equal 0. We have here the first equation, but I'm going to rearrange it, so this number goes to the other part of the equation. To do this, I need to add 20 on both parts of the equation. R1 plus R2, and now minus 20 plus 20 is 0, equal 20. So this is the result from the first step. Step 2. The sum of the moments around the point is 0. This point is called the pivot, and we need to place it in the beam. I will place it at the left end of the beam. Before calculating the moments, I'm going to determine if they are positive or negative. I will start with the force of 20 kilonewtons. This force is going to push down the beam, and the beam is going to turn in a clockwise direction. Clockwise moments are positive. Now I'm going to continue with the reaction force 2, and this force is going to push up the beam, and the beam is going to turn in an anti-clockwise direction, which means that this moment is negative. Now I can start calculating the moments. To do this, I need the formula of the moment, which is force times distance. The distance is between the force and the pivot. The moment of the force of 20 kilonewtons equals the force, which is 20, times the distance between the force and the pivot, which is 2. And this is 40 kilonewtons because the force is in kilonewtons, times meters because the distance is in meters. The moment of the reaction force 2 equals the force, which is R2, we still don't know what the value is, times the distance between the force and the pivot, which is 6. 6 R2 kilonewtons meter. The moment of 40 kilonewtons meter is positive because it's clockwise, and the moment of the reaction force 2 is negative because it's anti-clockwise. Now I can apply the equation of equilibrium. The sum of the moments is 0. 40 minus 6 R2 equal 0. Now I need to rearrange this equation. I need to add 6R2 on both parts of the equation. So 40 minus R2 plus R2 is 0 equals 6R2. Now I need to get rid of this 6, and I can do it divided by 6 both parts of the equation. 40 divided by 6 equals 6 divided by 6 is 1. 1 times R2 is R2. And 40 divided by 6 is 6.6 recurrent, but I'm going to round it to 2 decimal places. So the answer will be 6.67 kilonewtons. Step 3. I will use the results from steps 1 and 2. In step 2, we already had the answer for R2. Now I'm going to use this formula from step 1 to find out the value of R1. R1 plus R2, I know that R2 is 6.67 equal 20. I need to rearrange this. I'm going to minus 6.67 on both parts of the equation. R1 plus 0 equals 20 minus 6.67. R1 equals 13.33 kilonewtons. So now we already have the answer for both reaction forces.